Hey class, this is lesson 322. We're going to learn how to deal with when you're taking percents of percents and find some things out about how the numbers are changed. To do that, we're going to look at some problems that deal with going shopping and two stores that have some different ways of reducing prices to sell things. Let's think about this to start with though. If you increase 100 by 20%, and decrease the result by 20%. So we're going to increase by 20, then decrease by 20. Is the result the original number, 100? Explain. Well, it kind of seems like it should be, right? You're going to go up by 20%, then down by 20%. The problem is that percents are portions, and when you take a portion of a bigger number, the same portion of a bigger number, you end up with a bigger amount. So let's just see how this looks. If we increase 100 by 20%, that means we have to add 20, because 20 is 20% of 100, and that's 120. Now when we decrease that by 20%, so we're going to take off 20% this time. We're taking off 20% of 120. 20% of 120 is more than 20% of 100. 20% of 120 is actually 24. So when we subtract 24, we end up with 96. So we end up with 4 less than we started. And that's because percents are portions, and a bigger portion, a portion of a bigger amount will be a bigger number. So let's do some problems with Barry's bargain basement sale. Now notice how he does it. For every month old, he adds another 20% discount. Till he gets to 4 months old, then he just takes 50% off the original price. Now Steve's Super Savings Store, if it's been there 1 month, he gets 10% off, just like at Barry's. If it's been here 2 months, you take another 20% off the already reduced price, so you get 10% off and then 20% off of that. And if it's been here 3 months or longer, then you take another 30% off the already reduced price. So you keep reducing the price. First by 10%, then whatever that price is by 20%, and then by 30%. One thing I hope you'll learn after this lesson is a quick way to do percents. Otherwise, we'd have to, for figuring out Steve's Super Savings Store, we'd have to use a lot of proportions to get the answer to a problem like that. So let's look at using these numbers here. Rashonda went to Barry's bargain basement to buy a pair of jeans. The jeans had been in the store for 1 month. The original price was $40. What was the sale price? So Rashonda is going to get 10% off. Well, if we think about what 10% is of $40, that's the proportion where we have the part over the whole. The whole is the original price, and that is 10%. So 100 times B is equal to 40 times 10, which equals, so B equals 400 divided by 100, which is 4. So we have to take off $4. So we're going to do 40 minus 4, which is $36. All right. So, and one thing that I'd like you to notice is that we always seem to be doing the same thing when we're doing a problem like this, when we're trying to find how much out of the whole we have. We can just take, we do times 10 and then divide by 100. Well, that's really just times 0.10. So I could, to get that 10%, I could just do 40 times 0.10, which is 4. So, and that's a lot quicker way to find the answer. What percent of the original price was the sale price? So our sale price here is $36, and we want to know what percent that is out of the whole original price. So we can do this proportion. 36 divided by 40 equals what percent? And so I would do 36 times 100, which is 3,600. And that's equal to 40 times n. Divide both sides by 40. And I get 360 divided by 4 is 90. So it's 90% of the original. Now, there's a connection there. If you take 10% off, you end up with 90%. So if I wanted to do that problem a quick way, and this is the way Mr. Hermanson would do it, knowing I'm taking 10% off, I would just think, well, my original price is 100%. My 10% discount means I'm paying 90%. And I would just do that in my head. And then I would say, well, so my sale price is just going to be 90% of the original. And so a quick way to get 90% of the original is just to take the decimal for 90% times the price, $40, and when you multiply that, you get 36. A really quick way to come up with the sale price. So we're going to use that idea in some of these problems. You can always use the proportion if you kind of forget how to do the percent, but try to do some using this new system. So Julie was a smart shopper. The pair of shoes she wanted had an original price of $50 at both Barry's and Steve's. The shoes had been in both stores for 2 months. How much would Julie pay for the shoes at Barry's? At Barry's, she gets a 20% discount. So we're going to take 20% off. Now we'll just think about that. If we take 20% off of our original price, which is 100%, 100% minus 20% means we're going to pay 80% of the original price. So I'm just going to take 50 times, and 80% is just the ratio 80 out of 100, which is 0.80. And 50 times 0.80 is 40. So Julie, if she goes to Barry, she gets them for $40. Now, if she went to Steve's, at Steve's you get a discount and then another discount. You get 10% off for the first month and then another 20% off the already reduced price for the second month. So at Steve's, we would start with our $50, and we would do the same thing for the first month, 10% off. So for the first month, we're going to take 10% off, and if I take 10% off my original price, which is 100%, I'll be paying 90% of the price. So I'm going to take 50 times 90%, and that's $45. That's for the first month. And then for the second month, we get to take 20% off that, so I get to take another 20% off. And if I take 20% off, that means I'm left with 80%. And so I do 0.45 times 80%, and I end up with and that's $36. These prices are different because at Barry's you just take 20% off once, but at Steve's you get to take an additional price off of that. All right. I think we'll do this problem with Jasmine's in class. I want to do maybe 1 or 2 more problems for you, and then the rest we'll do in class. But let's do this number 4 here. Omari found a sweatshirt at Steve's with an original price of $30. If the sweatshirt has been in the store long enough to earn the 10% discount, how much will Omari save? Omari will save 10% of 30. So we can just do 30 times the decimal for 10%, and that equals $3. So he's going to save $3. Okay? If the sweatshirt has been there long enough to earn the 20% discount, how much would he save from the original price? Well, remember now we have to take that discount off of the discounted price. So if we start with our $30 and take off 10%, that means we're going to pay 90% of the price. So now I'm down to $27. Then I take another 20% off of that. So if I take 20% off, that means I'm paying 80% of that price. And that is, and that equals $21.60. Now we can see that we've started with $30 and we're now paying $21.60. So if I subtract those two, that means I'm getting $8.40 off. So question C says, is the dollar amount of the second discount twice the dollar amount of the first discount? Explain why or why not. No, if we did twice $3, that would be $6. And we're not taking 20% off, we're taking 10% off and then another 20% off of that. So we're taking off a little bit more. All right, so Amari calculated the final price this way. First I take 10% off, then I take 20% off. So altogether I'm taking 30% off. That's $9. So the final price is $21. Is Omari correct? No, he's not correct. The way he did it, he's taking 30% off of the original, and the second 20% off isn't off the original, it's off the discounted price. The already discounted price. So you're not getting quite 30%. So if Amari buys a sweatshirt after it's been in the store for 2 months, what is the total percent discount from the original price? The total percent discount is, we know that he's saving $8.40, so I'm going to use that answer. And $8.40 from the original price of $30. And as a percent, so I'm going to take 100 times 840, which is 840. And that's equal to 30 times n. So I need to do 840 divided by 30, which is 28%. So it ends up being a 28% discount, not quite 30%. All right. So I hope you can use some of these strategies in solving the problems. And that's the end of the video. I'll see you tomorrow in class.